All right, guys, this is video number 3 in the detection engineering series. And I know in the last video I said I was going to set up Caldera in this video, but there's a slight change of plans. There's another topic that I would like to touch upon before we start expanding our lab, and that is detection as code. Why detection as code? If you remember in the last video, we had saved our custom rules to a text file locally on the Parrot machine here, which works for the last video because I was just setting things up. But going forward, that wouldn't be we wouldn't be following best practices if we did things that way, because when our custom detection rules, when it grows in number and when it gets more complex, we will appreciate having some sort of version control, and it would be a lot better if we had detection as code CI/CD pipeline for automation. And this is what we're going to set up in this video. I've already mentioned there's two benefits to setting detection as code CI/CD pipelines, and one is for automation. Second is to have different versions of the same detection code, so that if something breaks, that you can roll it back to a working stable version. And this is where the industry is heading, right? There's a great article by Splunk blog on detection as code. It explores detection as code in a lot greater detail, which you can check out if you're interested. I'll leave a link in the video description. Now, this is where we are. If you remember from the last video, this is where we are with the home lab setup. We haven't really changed much. And in this video, this is what we're going to do. I'm going to set up, I already have set up GitHub repository for my custom Wazuh detection rules. I have called that Wazuh detection rules. It is a private repository, so you can't see that if you're trying to access it. And that is where I'm going to save all of my detection rules. So this is what it looks like right now. If I go to my GitHub profile, go to repositories, and go to Wazuh detection rules, there's not a lot going on at the moment. There's a README file, but that's about it. But this is where I'm going to store the local rules.xml file, which will have all of my custom detections, and that will be pushed to my Wazuh server, and the Wazuh server's manager would be restarted every time there's a code update. If all of that just flew over your head, stick with me. As we progress and as we start implementing things, it'll make more sense to you. Let me walk you through the current lab setup. The current lab setup is this. If you've been watching the videos, you know the setup already, but if this is the very first video that you're seeing in the series, I want this video to still make sense to you. So I will quickly walk you through the setup that I have here for this detection engineering exercise. There's a pfSense firewall, which acts as the router and the firewall and the gateway to the internet. So 3 network interface cards. There's 2 virtual networks, one of which is called the victim net. This is where I'm planning to do all my testing. And there's another virtual network called MonitorNet, which has all my monitoring appliances. At the moment, there's only one Wazuh server, but in the future, if I want to expand my setup, I will have. And if I want to introduce other security solutions, that will also sit in the MonitorNet. In the victim net, the Windows 11 machine is where I'm going to do all of my testing. The Parrot machine is where I'm going to initiate my attacks from, to create those logs. So then I can build the custom detections on top of those logs. In today's video, we're going to set up a GitHub self-hosted runner, which is going to run on the Wazuh server. Why self-hosted? Because cloud-hosted runners, I had the option of setting up. I still do have the option of setting up cloud-hosted runners, but I don't want to do that because I would have to expose my Wazuh server to the internet, and I don't want to do that. The next best thing to do is to run a self-hosted runner on the Wazuh server. which is what we're going to do in today's video. What the self-hosted runner will do is it will constantly check the GitHub repository for any changes to the code. And if there's a change, it will run a set of actions. For me, in this case, that's going to be if it detects any code or rule changes in the repository. So anytime I make a new change to the rules, it will detect that. And as soon as it detects that, it will copy the newly created local rules, your XML file, onto Wazuh. It saves it in this directory in Wazuh. It will replace that file, and after it's done that, it will restart the Wazuh manager. And according to Wazuh's official documentation, it's best practice. That's what Wazuh recommends as well, to restart the Wazuh manager every time a rule is updated. It does it automatically. It's supposed to do it automatically. In the last video, when I created a rule, it just did that automatically. Yeah, but as good practice, and to ensure the rules, the update takes place, it's good practice to restart the Wazuh manager, which is what I'm going to do. First things first, actions. We go to GitHub. I'm going to assume you know how to set up a repository in GitHub. It's just 2 clicks, log into GitHub and click on new repository, name it whatever you want to name it. You don't really have to have a README file, but this could serve as a wiki. If we have custom like naming conventions or whatever, this could be the wiki, the guide. So to set up this GitHub runner, I'm going to create this repository, which I've done. Let me copy the local rules or XML file that we modified in the previous video. If you don't know where to find this, click on the hamburger menu, go down to server management, rules, and search for local rules and click on edit. This is the contents of the local rules or XML file. What I've done is I've copied this and I've created a same directory structure locally on the parent machine. So in my documents folder, I have the folder called Wazuh detection rules, inside which I have a readme.md, which is the same file that you saw on the GitHub repository. And then there's the local rules.xml file, which you can see that's present on my local machine, but there's no local rules.xml in the GitHub repository. So first, we're going to push this change to GitHub. So open a terminal, go to cd documents, Wazuh detection rules, and then add everything to git. Let's commit give it a message. So local rules.xml first upload. This string between those 2 quotes can be anything. That's just a message that we're sending here. So git commit, that's done. Git push origin main. It's pushed it to the main branch, and if I now refresh this page, I should see the local rules.xml file, and I do see it. Perfect. Git is working as expected. We can move on to the next step, which is to create a YAML file to deploy the changes anytime there's an update to the code. For now, we'll just create an empty YAML file. So if I create a folder here and name that github.github, we'll have all of our workflows saved within the GitHub directory. So if I open GitHub and create another folder called workflows, and then within this folder, I'm going to create a YAML file. So if I go back to .github Okay. cd.github/workflows, and if I create a YAML file, call it deploy.yml. I'm going to leave that blank for now. Just want to create that file, but we'll come back to that. This YAML file is where we're going to define our actions, our action steps every time this workflow is run. Okay, now I'm going to go back to the Wazuh detection directory, make sure everything is as expected. There is a .github directory in here. Now I'm going to I'm going to download and install the self-hosted runner on the Wazuh server. So if I go back to the home lab network environment diagram, this self-hosted runner is a program, is an agent program, whatever, that will run on the Wazuh server. Right now we haven't installed it. This is what it looks like. But the next step is to install the self-hosted runner. How do we do that? We go to GitHub, go to repositories, choose the Wazuh detection rules repositories or whatever you called it. Go to settings, click on, there should be runners somewhere here. Actions, and then click on runners. There are no runners, but we need one self-hosted runner. So click on new self-hosted runner. Choose Linux x64. And these are the commands that we will have to run on the Wazuh server. So I can directly run these commands here on the Wazuh server, but it's a bit laggy when I run commands in here. So I'm going to SSH into Wazuh through my parrot machine. I already have done that. I'm logged into Wazuh as a Wazuh user. And I'm going to now run these commands. So where I'm in the Wazuh user home directory. Don't see anything here. So I want to create a folder. Call that actions runner and move into that folder and then download the runner here. So I'm going to copy that in, paste. Copy, paste, enter. I know why, because we're trying to download files from the Wazuh server, but the Wazuh server doesn't have internet access, so I have to download this locally first. How do I do that? Open a new tab, copy this command, and I'm going to go into desktop, paste the command. If you remember, the endpoints in this victimnet can talk back to the Wazuh management server, but the Wazuh server doesn't have internet access. So when I was trying to download the self-hosted runner on the Wazuh server, it was failing to download. However, the parrot machine can connect to Wazuh server. So we've SSH'd into the server, all okay, but we couldn't download a file from the internet. So what I'm going to do is I'm going to, since the parrot machine has internet access, I'm going to download that file on the parrot machine, and then I'm going to set up an HTTP server and then download that file to the Wazuh server. Hope that made sense. If I hit ls, I should see the actions runner file in here. What I'm going to do is I'm going to run a Python 3 HTTP server AZAT and go back to Wazuh, copy this paste that in there, but instead of HTTPS GitHub, it's going to be HTTP 192.168.50.10. Copy that. So all I've done is I've replaced the original URL with the parrot URL because the parrot is now hosting that file, if that made sense. And if I hit enter now, it should work. Okay, that took slightly longer than I expected. I had to create some firewall rules to allow that file transfer. But now that we have the file on our Wazuh server, which is here in this directory, home Wazuh user actions runner, and this is the file that we just downloaded. There's an optional step in here where you check the file hash, which is good practice if you're downloading things, but I'm just going to skip that and then run this command in here. So if I copy paste that and hit enter, that's extracted it. Okay, there was a little bit of a hiccup there, but I had to regenerate another token, and we're now at this step where we're gonna run this config script. So if I paste in command, hit enter, this should now work because we have a valid token. Enter the name of the runner group. Enter for default, enter the name of the runner. I'm going to name this Wazuh server. This runner will have the following labels, blah, blah, blah. Press enter to skip. Name of work folder, hit enter. Yeah, I didn't really have to change much, just hit enter a few times. And now we can execute the run.sh script to run the self-hosted runner, but we're not going to do that because we want this to run as a service. Reason being, if I had to run this here and if I had to like exit or close this for whatever reason, it would stop running. But if it ran as a service, then it would always run in the background, if that makes sense. And to run that as a service, I would have to type in sudo /svc. There is, by the way, there is the svc.sh script in here, and we are going to set that up as a service. So sudo svc.sh install, hit enter, then sudo.svc.sh should start that service, and it's active here. So now we have the service, the self-hosted runner running on the machine, which we can verify if we go back to runners. There's Wazuh server, which is what we named this runner. And as you can see, it's idle here. So far, we've created a GitHub repository. We've copied the rules. We've installed the self-hosted runner, which is actively monitoring for any code changes. Before I change anything, let me verify if we are getting in any event data from the agent. Go to active. If this doesn't work, we can just click on the hamburger menu and go to threat hunting, and then click on event. Okay, so we will now generate a few we will generate a few who am I events. So if I run who am I a few times and then go back to Wazuh server, make sure we're seeing the Windows 11 agent, it is active. If I go to the Windows 11 threat hunting page and click on events, I should see who am I. I ran who am I thrice, and I see that 3 times here. And this is now raised as a rule level 7. I'm going to make a change here to the rules.local XML file in the GitHub repository. And when I make that change, this should automatically update. And we're going to achieve that by defining some steps in the deploy.yaml file. So I've opened this. If you remember, we placed this in the Wazuh detection rules. There's a hidden directory here. If I go to .github, I will see workflows, and if I open workflows, the YAML file is placed here. I'm going to paste in some content into this YAML file, and I'll explain what we've just done. The name of this deploy YAML file is called deploy Wazuh rules, and on push, it's pushed to the main branch. This is where it saves. I've created, so what I've done is I've created in the Wazuh detection rules, I've created a rules directory where I'm going to place the rule. And that's the paths that we've defined here. And the job is to run on the self-hosted runner. This is a step that I've seen in many YAML files. I don't really understand why it's done, but that's for me to do some research on after the video. And these are the exact steps that are carried. These are the exact actions that are carried out on the machine. So this job, it copies rules to Wazuh. So we copy, since it's in a system files location, you would have to run this as sudo. So sudo, we're copying in the rules that we just updated in GitHub, in our GitHub repository, to our local machine here. And we're essentially replacing the local rules with the most updated local rules or XML file. And after this job is complete, we are going to restart the Wazuh manager for the rules to take effect. So this is the command that we're going to run. Again, this is you're restarting a service, so you would need root privileges to do that. Okay, and now we're going to save this. This YAML file will run. It dictates. It has the actions to be carried out when the CI/CD pipeline is run. So if I now go back to okay, there's another issue. When this runs, it's going to run as the Wazuh standard user, which is Wazuh user here. And Wazuh user doesn't have enough permissions to run these commands because some of these are privileged, they're sudo commands. And when this executes, you would be challenged for a root password here, which is not good because we're trying to automate this. So what we're going to do is we are going to give the standard user here the permissions he needs to run these without or as root. Yep. So how are we going to do that? We are going to go to Wazuh server and type in sudo and go all the way down and type in Wazuh user, the name of the user, standard user, and type in no password for user bin cp, which is the copy command for Wazuh user actions run work, I think we called it. Repository is Wazuh detection rules. What was the detection rules local rules.xml, and the OSC rules.xml. This is where Wazuh saves the local rules. And lastly, we also need to add user bin system ctl restart Wazuh manager, because basically we have to allow the standard user to run copy and the locations that they're allowed to run it in, and systemctl to restart the Wazuh manager service. Yeah, this should work. Everything is as expected. There's now we're going to go back to our local user in here and go to the Wazuh detection rules, go into git add, wait, actually my bad, we need to make some changes to the rules first. So if I go to cd rules, list the contents, and then cat local rules, we're going to make one small change to this rule. At the moment, it raises these events as a level 7 rule, but we're going to change that to a level 8 in here. Yeah, so if I change that to nano local rules, and then change this to level, let's do 9. Save this. Okay, now git add dot git commit, let's add a message that is to rule who am I changed to rule level 9, because that's what we did, and then git push origin main. Okay, that's the changes have been pushed. Refresh this. Who am I changed to rule level 9. And now if I go back to Wazuh, if I open the Windows 11 machine, run who am I again, and then go back to Wazuh, give it a few seconds, and then hit refresh, I should see, if everything worked fine, I should see a who am I rule come through. Yep. So there is a who am I rule with level 9. And now we've successfully set up our detection as code CI/CD pipelines. That was a long one. I'll see you in the next video.